memory management. So OS also takes care of your memory management. Okay. So when we talk about memory management, which memory are we talking about? There are many types of memory. You saw that, right? Which memory are we talking specifically? Your main memory. Okay, your RAM. So in main. Okay, so in memory management, we see about your main memory. Okay. So main memory, it is volatile or non-volatile? Main memory or your RAM, whether it is volatile or non-volatile? Volatile. Okay, but there are also non-volatile RAM in markets. Okay. Okay. So we saw that why this main memory management is important. The OS will take care of this memory management. Why is the main memory management very important? It is important. Why? You have two types of fetch cycle. Okay, note that down. One is instruction fetch cycle. Okay, you correct instructions or data. One is instruction fetch cycle, and one is data fetch cycle. Okay, data fetch. From your main memory, or you can fetch some instructions or you can fetch data. Okay, there are two types of fetch cycles: instruction fetch cycle and your data fetch cycle. Both will be done from your main memory only. Okay, so your main memory management is very important for CPU efficiency and speed. Okay, no address. Okay, absolute address. Management in Maramude, we talk only about your main memory only. Okay, so main memory is like the values மட்டும் தான் CPU ல access பண்ண முடியும். Okay, CPU work பண்ணனும்னா first main memory ல இருக்கிற value தான் எடுக்கும். Okay, so main memory is very important because it is directly proportional to your CPU. Okay, so the main memory ல first என்ன பண்ணனும்னா ஒரு address will be created. அந்த address பேர் தான் absolute address னு சொல்றோம். ஒரு absolute address create பண்ணிட்டு அதுல தான் உங்களோட program வந்து map ஆகும். Okay, அப்புறம் CPU வந்து இங்க இருந்து it will take the data, it will process. Okay, if the task is over, this memory will be free. This memory will be available for another process to come. Clear? This is absolute address. Whenever you have a process to be executed, inside the main memory, an absolute address will be created. Okay, an absolute address will be created and it will be mapped to the program or the process to be executed. Okay, if a user வந்து ஒரு application software இருக்கு, ஒரு user program உள்ள வந்து வெச்சுக்கோங்க. It has to be in main memory, correct? அப்ப வந்து ஒரு absolute address will create ஆயிடும். Okay, one address will be created in main memory for that program. Okay, so that program or that process will be mapped to this address. Okay, is this clear? So in main memory, a temporary address will be created and it is called as absolute address. And that absolute address will be mapped to your program or your process. And after that, your program execution, your task execution will take place. After completing of the program execution, this will remain empty. Okay, an address will be created. That next time address will be deleted also. That space will be deleted. Is this clear? Your address will be allocated and deallocated. ஒரு process இருக்குனா main memory ல ஒரு address create பண்ணிட்டு that is called as absolute address and it will be mapped to the program. Program execution முடிச்சது கழிச்சு that address will be free. The concept clear? Is this concept clear? Is this concept clear? Okay. So in memory management, what does your OS does is it allocates and deallocates the absolute address or in your main memory. Okay, that's the point note பண்ணிக்கோங்க. Process memory management la OS enna பண்ணுதுனா it will allocate and deallocate the address. Okay, that is first point. Allocate, deallocate. Okay, it will allocate, deallocate. Next, it will decide which process or data to enter into that address and leave that address. There will be n number of processes, okay, trying to enter the main memory. Your OS only will decide which should enter and which should not enter. Okay, இல்லனா இந்த ஒரு அட்ரஸ்க்கு எதை allocate பண்ணனும்னு OS னா டிசைட் பண்ணும். ஓகே, இல்ல எந்த process போகணும் only one process will be executed at one time. Okay, and third point is it should know the data of who is using one memory. Okay, assume that if 100 is one memory and it is being used. So your OS should have the data of who is using that memory, which process or which data is using